In this video, we'll get to run our height above channel tool, the first in our riparian assessment toolset. This tool is going to calculate the elevation difference between a grid cell and a DEM, and then the stream channel cell that will receive the flow from that cell. In other words, from a cell within a DEM, it's going to follow the flow path all the way to the stream. And the stream channel cell that it ends up in is the one that will be used to calculate the elevation difference from. This is going to be used to estimate the extent of a low-lying area along the riparian corridor. Alrighty, so let's go ahead and run our tool. We'll go to our toolbox, finally go to the riparian assessment tool set and open up the very first tool, height above channel. You can see we have 4 inputs: our unfilled DEM, a flow direction raster, our stream reach feature class, and then our Z factor. We're going to get 3 outputs, 2 if you don't choose the optional one. The first output is the adjusted flow direction raster. Our second required output is the height above channel raster. And then optionally we can also generate a relative elevation raster. So let's go ahead and populate and let this run. So we'll grab our new DEM and put that into the unfilled DEM slot. You can see these were automatically added. I'll type in my Z factor. We have our adjusted flow direction and height above channel rasters automatically populated. And then I'm also going to create a relative elevation raster. So we navigate to our file geodatabase, give it a name. I'll just do rel11. And as always, I'm ending this in my 12-digit HUC ID. We hit save. Everything looks good to me, so we'll hit OK. Let it go. That optional output that I did choose to create, that's the relative elevation raster. The results are a continuous raster of elevation difference relative to the channel elevation. So basically from the channel, how high is everything around it? The relative elevation grid is reclassified into depth categories, and this is what makes our height above channel grid. It can be used as a proxy for water table depth, so you get an idea of very low-lying areas have a shallower water table compared to areas that are higher up compared to the channel. Their water table is likely to be much deeper. The height above channel grid is going to be an essential part of the riparian function assessment toolset. Alright, so my tool just got finished running and it looks crazy. So we have our adjusted flow direction, our relative elevation, and then our height above channel. So our adjusted flow direction is very similar to our original flow direction, so I'm just going to turn that off. We know what that basically means. Same with the relative elevation, it's going to be very similar to a DEM, so I'm just going to turn that off. Then we're left with our height above channel. So looking around, we can get an idea of our water table depth. That's what we can learn the most from this, besides sort of the shape of the channel and floodplain. So like along here where I have these patches of less than 1.5 meters above the channel, or like this large area down here that's going along this floodplain of the larger river, we know that our water table depth is fairly shallow, meaning that it's close to the surface, compared to these other areas that are 1.5 meters or greater, or higher than the channel, I should say. There, our water table is going to be deeper. So that is some valuable information you can get from your height above channel raster. So here's a brief recap on the height above channel tool. The results from it will be used in the riparian assessment tools which are to follow.